Hi students, welcome to the chapter on arithmetic progression. Arithmetic progression is any sequence of numbers either in the ascending form or in the descending form. The first of its term is known as A1 and it has a common difference between all the terms in the sequence. It has n number of terms. So it takes the form A being the first term and D being the difference, A plus D, A plus 2D, A plus 3D, A plus 4D, and so on up to A plus ND. And the common difference could be either positive or negative. If common difference is in the negative, then it could take the form A minus D, A minus 2D, A minus 3D, A minus 4D, and so on up to A minus ND. The sum of all terms in the sequence is given by the formula Sn is equal to n by 2, where n stands for the number of terms, within bracket 2a, a is the first term, plus within bracket n minus 1, n again is the number of terms in the sequence, multiplied by d. That is, Sn is equal to n by 2 within bracket 2a plus n minus 1 into d. Then the nth term value is found by the formula an is equal to a plus n minus 1 into d. The nth term value can also be found when the sum of the terms is given by the equation an is equal to Sn minus Sn minus 1. The sum of n terms can also be found when the first term and the last term is known. That is equal to Sn is equal to n by 2 within bracket a1 plus an, where n is the number of terms, a1 is the first term, an is the last term. The sum of first n positive integers is given by the formula Sn is equal to n into n plus 1 by 2. Thus, the sum of first 10 positive integers is equal to 10 into 10 plus 1 by 2, that is equal to 110 by 2, that is 55. I will now pause for a minute for you to look at the next 3 slides and note down the formulae therein. And thereafter I will be explaining the problems in the slides that follow. In the first slide, you are given a sequence of numbers, that is 1, minus 2, minus 5, minus 8, minus 11, and minus 14. We need to say whether this is an arithmetic progression or not. If the common difference is the same between the numbers in the sequence, between the successive numbers in the sequence, then it is an arithmetic progression. For example, the difference between the second term and first term, 1 and minus 2, is minus 3. And the difference between the third term and the second term is also minus 3. And the difference between the fourth term and the third term is also minus 3. Therefore, this is an arithmetic progression. A is equal to 1, first term, common difference is minus 3. Then in the second problem, 1, 2, 5, 8 and 12, the difference between the first and the second term is A2 minus A1 is equal to 1. The difference between the third term and the second term, 5 minus 2, is equal to 3. Therefore, the difference is not common as it varies from term to term. Therefore, it is not an arithmetic progression. In the third sum, root 3, root 6, root 9, root 12. Is it an arithmetic progression? Now the second term minus first term, a2 minus a1, root 6 minus root 3 is equal to root 3 into root 2 minus root 3. The difference is therefore root 3 within bracket root 2 minus 1. Now going to the third term and second term, a3 minus a2 is equal to root 9 minus root 6. That takes you to, that is root 3 into root 3 minus root 2. The common difference is not the same here also. Therefore, it is not an arithmetic progression. In the next slide, you are given an arithmetic progression in the form of 5, 8, 11, 14, 17. There are 20 numbers in the sequence. You have to find the sum of all 20 terms, and you have to use the formula Sn is equal to n by 2 within bracket 2a plus within bracket n minus 1 into d, where a is equal to 5, the first term, d is common difference 3, and n is equal to the number of terms in the sequence. That takes you to 20 by 2 within bracket 10 plus 19 into 3. Therefore, it is 670. In the fifth problem, find the 31st term of an AP whose 11th term is 38 and the 16th term is 73. Now, 11th term of a sequence, arithmetic progression sequence of numbers, is given by A11 is equal to A plus n minus 1 into D. A11 will be A plus n is 11, 11 minus 1 into D, that is equal to 38. That takes you to A plus 10 D is equal to 38, equation 1. Then A16 is equal to A plus n minus 1 into D, that takes you to A plus 15D, which is equal to 73. Solving equation 1 and 2, you get D is equal to 7 and A is equal to minus 32. A is the first term. Therefore, the arithmetic progression sequence is minus 32, minus 25, minus 18, minus 11, minus 4, plus 3, plus 10, and so on. Therefore, its 31st term, A being minus 32, D being 7, A31 will be A plus n minus 1 into D. That takes you to 178. In problem 6, if the third term of an AP is 4 and the ninth term is minus 8, which term is 0? Now S3 is equal to A plus n minus 1 into D, which is equal to 4. That is A plus 2D is equal to 4, equation 1. S9 is equal to A plus n minus 1 into D, therefore A plus 8D is equal to minus 8, equation 2. Solving from equation 1 and 2, you get D is equal to minus 2, A is equal to 8. Now, the term which is 0, the term value which is 0 is equal to 0 is equal to A plus n minus 1 into D. Therefore, 0 is equal to 8 plus n minus 1 into minus 2. That takes you to 10 minus 2n is equal to 0. That is 10 is equal to 2n, n is equal to 5. Therefore, the fifth term of this AP is 0. In the next problem, find the 20th term value from the end or last term from the following arithmetic progression. Then 3, 8, 13 extending to 253 being the last number. Therefore, A is equal to 3, D is equal to 5, last term is equal to 253. Number of terms in AP is equal to number of terms in AP is equal to A plus n minus 1 into D, which is equal to 253, that is AN. Solving this equation, you get 5n minus 5 plus 3 is equal to 253, 5n minus 2 is equal to 253. Therefore, 5n is equal to 255. So, n is equal to 51. That means there are 51 terms in the arithmetic progression. Now, the 20th term from the end is given by the number of terms in the AP sequence 51 minus 20 plus 1, that is the 32nd term. So 20th term from the end is the 32nd term. 32nd term from the beginning equated to 20th term from the end. The 20th term from end is calculated by the formula number of terms in the AP n minus term from the end plus 1. That is 51 minus 20 plus 1, which is equal to 32nd term. Therefore, A32 is equal to A plus n minus 1 into D. That is A plus 31 into D. That gives us 158. Now find the middle terms of an AP from 20, 16, 12 going down to minus 176. AN is equal to A plus n minus 1 into D minus 176 AN, that is the last number, is equal to 20 plus n minus 1 multiplied by minus 4. Therefore, it takes us to minus 4n is equal to minus 200. So, there are 50 terms in this AP. The 50 terms in the AP is an even number. Therefore, n minus 2 and n minus 2 within bracket plus 1 are middle terms. That is, 25th and 26th term are middle terms. So, A25 then is equal to A plus n minus 1 into D. That is minus 76. A26 is A plus n minus 1 into D. That is minus 80. Therefore, the middle terms value A25 is minus 76 and A26 is minus 80 respectively. If the nth term value is given as AN is equal to 2n plus 3, find the value of 15th term and the AP sequence. AN is equal to A plus n minus 1 into D. AN is equal to 2n plus 3. Substituting the values of n from 1, A1 is equal to 2 multiplied by 1 plus 3, which is 5. A2 is equal to 7. A3 is equal to 9. Therefore, A is equal to 5 and D is equal to 2. The 15th term then, A15 is equal to A plus n minus 1 into D. A plus 14 into D, that is equal to 33. How many 3-digit numbers are divisible by 7? 3-digit numbers range from 100 to 999. Divide 100 by 7. So you get 14 as quotient and 2 as remainder. So 14 into 7 is 98. And then if you add 7 to this, it takes you to 105. Therefore, the first number divisible by 7 in 3 digits is 105. Therefore, A is equal to 105. And then the common difference there, D is 7. So dividing 999 by 7, we get the quotient 142 and the remainder 5. Therefore, 994 is the last number that is divisible by 7. We have to find how many numbers are there in this sequence. That many numbers are divisible by 7. Therefore, A is equal to 105, D is equal to 7, AN is equal to 994. Substituting that in the formula, AN is equal to A plus n minus 1 into D. 994 is equal to 105 plus n minus 1 multiplied by 7. That is 7n is equal to 896. So the number of terms in this sequence is 128. So therefore 128 numbers are divisible by 7. For your exercise, you can find how many 4-digit numbers are divisible by 102. The answer will be 89. Try yourself. The AP consists of 50 terms. If the third term is 12, last term is 106, find its 29th term. A50 is equal to A plus 50 minus 1 into D, which is equal to 106. That is A plus 49D is equal to 106, equation 1. A3 is equal to A plus 3 minus 1 into D. That is A plus 2D is equal to 12, equation 2. Solving from equation 1 and 2, we get D as 2 and A as 8. Therefore, A29th term, A29 is equal to A plus 29 minus 1 into D. That will take you to 64. If sum of n terms is given by the equation Sn is equal to 5n plus n squared, find the AP and the value of its 15th term. An, that is the last number value, is found by the formula sum of n terms minus sum of n terms minus 1. That is Sn minus Sn minus 1. Substitute n minus 1 for n value in the formula. That is, if Sn is equal to 5n plus n squared, then S n minus 1 becomes 5 into n minus 1 plus n minus 1 whole square. That takes you to 5n plus n squared, that is for Sn, minus within bracket for Sn minus 1, 5n minus 5 plus n squared plus 1 minus 2n, using n minus 1 whole squared for a minus b formula. Here, in the second term, n is substituted with n minus 1. So 5n becomes 5 into n minus 1 plus n squared becomes n minus 1 whole square. That takes you to 5n plus n squared minus 3n minus 4 plus n squared. Solving that, you get an as 2n plus 4. An is equal to the term value. An is equal to given by 2n plus 4. A1 is equal to substitute 1 in n, therefore 2 into 1 plus 4 is equal to 6. That is, first term is 6. A2 will be 8. A3 will be 10 as explained in the slide. Therefore, the arithmetic progression is 6, 8, 10 and so on. A is equal to 6 first term, D is common difference. Therefore, the 15th term, A15 is equal to A plus n minus 1 into D, that is 6 plus 15 minus 1 into 2, that is 34. Thank you.